Hi, everyone. Welcome to another exciting session of the Lambda Test XP series. Through the XP series, we dive into a world of insights and innovation featuring renowned industry experts in the testing and QA ecosystem. I'm your host, Kavya, Director of Product Marketing at Lambda Test, and it's a pleasure to have you with us today. Today, we are diving into a topic that's redefining how we approach software testing, which is basically observability in software test modernization. In an era where digital experiences must be seamless and reliable, understanding real user interactions and monitoring performance is crucial, which is exactly why we have the guest of today's show with us over here. Before we dive in, let me just introduce you to someone who truly embodies the spirit of innovation and resilience in the tech space. Donovan or Donny Mulder, who is Chief Executive Officer at KineticSkunk IT Solutions. As the founder and CEO of KineticSkunk, Donny has been instrumental in shaping cloud infra, observability, and DevSecOps practices in partnership with industry giants like AWS, Azure, GitHub, and Red Hat. So before we move on to the topic further, let's hand it over to Donny. The stage is yours. Please let our audience know a little bit about yourself.
Thank you so much. Thanks for having me on this podcast. It's an honor. Okay, I've been in software quality or automated testing since the mid-90s, so about 27 years now. And in that space, I've seen the ebb and flow of automated testing when it just came on the scene and it was sort of quite unsuccessful and it became shelfware. And then later on, it got off the shelf, new and different approaches to automated testing became available, more research went into it, etc. So I've seen the ebb and flow of automated testing for nearly 3 decades. And being in testing for so long, and quality has always been I can say, a driving force for me personally in my business, for myself. And but more importantly, in business, how to measure quality, right? And that's a massive thing, because I mean, you can only measure if you got proper baselines. So I've spent a lot of my career focused on how to measure quality. I've done some research in this space. Got a couple of conference papers and a journal paper in the software quality space. And I've really taken that and built it into the business. And and that's how KineticSkunk got started, focusing on automated testing, and then the natural flow from there is to bring in CI/CD, because it's good to know your test results. It's even better to know your test results earlier, right? And so, with the way I see it, we're in the business of risk mitigation. And risk mitigation is all about getting your information as early as possible to make decisions as quickly as possible, right? So it's bringing us on to our topic.
That's amazing. You have done almost everything in the testing
Mm.
ecosystem, Donovan, more or less. Very impressive. So let's start with the first question that we have for you, which is how does real user monitoring differ from synthetic monitoring in terms of data collection and insights?
Yeah, that's a great question. So, synthetic monitoring is like sending bots to your test app in a clean control
Hmm.
environment. Helpful but limited. Real user monitoring, or RAM, flips that data collection to collecting actual data from users in the wild, right? So you get to see things like errors, page load, issues, what device types they're using, where in the world they are connecting to your site. And you get that from real sessions. And that becomes quite valuable. because it shows you what your users are really experiencing, not just what the test scripts say they should be experiencing.
Very interesting. And moving on to the next one, which is what are some of the best practices for implementing feedback loops between production monitoring and pre-production testing?
Okay, so that's best practices. So we can get into there's quite a few best practices, right? Observability, amazing that you can observe and stuff like that. But you go right down to, let's say, when your developers are writing the code and stuff like that, do they actually have a strategy for implementing the logging of what's happening at that application, right? And that is like sort of the first principles part, right? You don't want to have a logging where you have gaps where in let's say in the execution of your code base, the code one class gets instantiated and maybe it's only one or two log messages coming from there and it bounces to another function or another method that's in another class. So you've got these gaps, right? So I always think or subscribe to the fact that your logging needs to tell you a story, right? It needs to tell you what's happening in the application. So that's the most basic area to start, or first principle area to start. And that also reduces the cost of observability. A lot of the observability tools, they charge, you get charged per log message, how many log messages are actually coming through, and they can drive up the costs significantly. And that is a barrier to entry. If I'm looking at in my opinion, the most important and best practice is get your login strategy right at the code level already, right? In production, what to be monitoring, things that make sense in the business. So you're a retailer, right? Or what's the most important thing? You want, let's say you want that car, you want your cart to be performant. If your cart is taking 10 seconds for someone to make a payment, I think, I don't know what the stat is, I think the stat is between 60 and 70% of your potential customers have abandoned that cart, So that's another best practice, tying observability to, it's called a business KPI, right? With the cart as an example for the retail industry.
Very interesting perspective, of course, and thank you so much for those valuable insights. So, moving on to the next question, right? How can QA teams use RUM data to make stronger business cases for investing in performance and quality improvements? Because I'm pretty sure that this is something that most of the organizations sort of struggle with in terms of understanding.
Yeah, great question. So to me, RAM or real user monitoring gives QA a superpower. QA can then show how slow things like slow load times, hurt conversions, while certain bugs affect your, let's say, your user community or your customers, right? And business will appreciate that because then they start to understand how what's happening in production affects revenue, affects reputation, right? It can be, you just look at reputational damage. The site is slow. People think, okay, or business think, okay, so what if the site is slow, right? But maybe in their minds, they're not making a connect between a slow site and the reputation, right? The reputation is we can't finish our transactions quickly enough on that e-commerce site. But that e-commerce site is super fast, might be a bit more expensive, but I can get my shopping done, right? So that's quite a big deal. So in South Africa, where I'm from, maybe about 2 years ago, there was this rage about prime water. I think actually it was around the world that everyone wanted to buy prime water. And a large retailer in South Africa got quite a bit of large stocks of prime water. They made it available on the e-commerce site, and the site crashed, right? Because there's just too many users or potential customers connecting. So not only could they not sell prime water, but whoever was doing their normal shopping, right? Because it was a retailer selling food, etc. Right? So whoever was doing their normal shopping couldn't complete the shopping. Those who were about to make a payment, the card couldn't complete it. So potentially losing millions of dollars, right? So yep. So correlating that data and understanding how your site performance affects revenue is super important. So if QA can now attribute bugs that they found to those real scenarios, real life scenarios, where they get the data from the real users, QA then becomes a critical business function. We know it's a critical business function, but it becomes a critical business function in the minds of business, right? Then suddenly QA is not seen as a grudge purchase. It's actually seen as a critical component of the business. So super important and very good question.
Thank you so much. And I was thinking about how, based on the examples that you provided, I mean, this can be implemented across different industries, for instance. It doesn't matter which industry might be dealing with a performance or quality improvement, matrices or questions, for instance. It can be respective of industry be implemented by QA teams.
Yeah, absolutely. Not just retail, every industry where you have
Yeah.
a means of interacting with your clients, it's apps, your
Yep.
website, any of those. If your systems are not performant, you're going
Mm-hmm.
to suffer reputational damage. You know, there's this something that's I don't really see discussed in the industry, right? So when you deploy a new feature, your user community are they're very forgiving about new
Mm-hmm.
features. But after deploying a new feature and that new feature causes a regression in
Mm-hmm.
existing features, suddenly you're interrupting how people go about their day. They
Yep.
expect those to work. And when you disturb or interrupt how someone goes about the day, they your user community becomes very intolerant of that. So yeah, it's an area that I think business
Mm-hmm.
in industry
Yep.
should use observability or real user monitoring to really protect their business.
Thank you so much, Donovan. That's really insightful. And moving on to the next question that we have, what are the approaches that helps teams to correlate user behavior patterns with performance degradation before even issues escalate?
Okay, so if I'm hearing you wrong, how can we use real user data to predict performance issues based on how the user community uses your application or consumes your application? So in performance testing, we have to put together load models, volumes, etc., and mimic how we think your user community is going to consume your application. So when it's a greenfields application, it's new kind of things, then we're very dependent upon synthetic users, right? Where we assume, we make assumptions that at a certain time of day, there's going to be a ramp up of users, or a certain time of month. In, let's say, after payday, your bank, people are going to, there's going to be lots of transactions, a lot of shopping, lots of activity, etc. So you can use that information to model how your user community is going to work. But over time, when you're doing the real user monitoring, you can start to collect real data about how your users consume or use your service or use your application, website, right? And based on that, you can then use that data to inform your test strategy. So let's call it the right-hand side informing the left-hand side. So we have what's a shift left. This is a big thing about shift left, bringing the testing left. Or now we know what happens on the right-hand side. The right-hand side, let's call it shift right, the monitoring, the real user monitoring. And that's informing the left-hand side. Right? So over time, you know how your users can consume your application. um, you know that if you introduce let's say just going back to retail, things are you're going to have a sale, it's a winter sale, it's a summer sale, it's a Black Friday, etc. You've got that data now, right? So you can then plan how your infrastructure should shrink and contract based on the user community, let's call it, the usage and pattern. And so you can plan for that, you can assign budget to increasing infrastructure consumption. You can do you can go to quite a granular level in your plan. So that's how, in my experience, that's how real user data will inform how you're going to set up your tests, how you set up your infrastructure to handle load for let's call it a special event.
Thank you so much. Yeah. Very interesting, and also the what we basically see is in terms of user behavior patterns in itself, right? Correlating that data and figuring out how the performance is basically affecting, getting affected, right? Most of the quality engineering leaders whom we speak with, for instance, they do. They are not able to spend a lot of time even digging through this data. So with these approaches, I'm pretty sure that they're able to build like a framework so as to handle it and approach it in a better manner.
Yeah,
Yeah.
absolutely.
So moving on to the next question, what challenges do global distributed teams face when implementing TestOps practices, and how can that be addressed?
Okay. There are several challenges, and it doesn't even have to be geographically dispersed teams. In an organization where you have siloed teams, I'm not talking about the silos between QA, Dev, and Ops, it's just silos between departments that make up a corporate. Potentially, each department is following their own way of doing testing, their own way of orchestrating test environments. That geographically dispersed teams becomes harder because you have to have effective communication strategies, and you're also probably more in need of a traditional test center of excellence, right? For your growth, and that informs strategy, informs how test execution environments are going to be orchestrated, test environments, so the target environment, how that's going to be orchestrated using tools such as Terraform, Helm, etc., to spin up your QA environments, dev environments, or pre-prod in order to test that. So in that respect, standardization of orchestration is really, really important. Test design, how you design functional tests, your approach to designing and building performance tests. It's also good to have that standardized. Because again, let's say if you have several teams, several dev teams, QA teams, etc., and something from QA needs to move to a different team, they shouldn't have to learn new ways of designing tests, right? Because that drives up your cost. The time for someone to become productive on a project also goes up. But just going back to test ops, you want a consistent way of doing so. If you have some years back, I worked for a big team for a bank in a major project where we had a deployment team in Adelaide, test team in India, Bangalore, a dev team in Moscow. I managed the test environments in London, and we had performance teams in New York and in California, right? So testing, deployments just happened around the clock, right? Back then, no microservices, nothing. But so highly dependent upon a single team somewhere in the world to make sure, in this case Adelaide, to be deploying effectively. But with microservices, Lambda architecture, or let's call it the cloud, basic cloud building blocks, any team these days should be able to deploy an environment they need to test, and they need to be able to test against those environments. So that's where TestOps, in my opinion, comes in and solves that problem. Tools such as Lambda test in the TestOps space solves that problem from a orchestration perspective. So we're just focusing on orchestration, whatever browser combinations, or devices you need to test against, right? That's all available. It's not like back in the day, one QA as an iPhone 5, another one has an iPhone 8 over here, and sort of all over the show. And getting defect resolution tends to be quite hard because with the devices are sprawled and all over the show.
That's an amazing insight, Donovan. Super helpful, of course. What also stands out is how, the complexity of managing test ops across global teams that's working remote, that's distributed in nature, is so real. But at the same time, with the strategic collaborations and approaches that you mentioned, and automation in itself, it can make a huge difference for the quality teams out there. So thanks for sharing those insights again. um, Speaking of yeah, go ahead, please.
But yeah, the big thing over there is standardization, right? With its
Yeah.
test design, test execution environments, etc. And that's something what TestOps brings to the table, or test orchestration at scale, but it's a consistent test execution environment. Brilliant.
Yeah. No, great. That's definitely insightful. And speaking of creating that a platform for QA professionals to basically thrive more, right? So, what are the skills and capabilities do QA professionals need to develop so that they are able to thrive in an observability-driven testing environment? This might again be a question that a lot of QA professionals must be wondering this, and at the same time, a lot of quality engineering managers and leads might be thinking about this. So, based on your experience, how have you gone about it?
Okay, so being in QA for such a long time and effectively running a software quality business,
Yeah.
us personally, us having to train graduates and bringing them through, through the different programs that we run, and also seeing what's happening in industry. So at KineticSkunk, we put a lot of energy into training graduates and bringing them through our program. And our program is structured for what the current demands in the market is. Right? So back in the day, running some tests, producing some test results where manually was great. And then we needed to automate that. Automation in the late 90s, early 2000s became shelfware. Not many people wanted to use it, heavy expense. And the problem there was is that where the people who started automating tests were not trained software engineers. Manual testing background, test analysts, business analysts, but they weren't trained on code, proper software engineering principles. So that stage, code and playback may seemed like a silver bullet, but yeah, it actually ended up being an Achilles heel for automated testing. Then people started actually understanding, learning that we as quality engineers, we need to know how to write code in order to automate this test to make tests more repeatable, manageable, reusable, etc. Right? And so let's call it from record and playback, we move to functional decomposition. From functional decomposition, we move to data-driven testing. From data-driven testing, we move to three-tier data-driven testing. From there, we move to keyword-driven testing. And from there, now we have behavior-driven testing. And there's other things such as model-based testing, etc. But essentially, as that evolution occurred, test engineers needed to know more and more the technical components with regards to automated testing. Along comes microservices, and suddenly with templating and with CI/CD, automation of deployments doesn't have to be solely with a DevOps team or with or a Linux team or anything like that. A normal test automation engineer or even a manual tester can execute a script to deploy into some Kubernetes environment. So again, having to know how to code, and databases, SQL, etc. And now, in this day, at this current juncture, it's having to know how not just how to design tests, but how to automate it, how to incorporate your tests into a CI/CD pipeline, understand DevOps, and how to deploy microservices. Great. About 3 or 4 years ago, I had a conversation with some other professional test engineers, and I said, our future test engineer needs to be a data scientist. They need to know data science, right? So here we talking about correlation of what's happening in the real world versus what's happening under the hood. So now we have all of this data available, right? And as a test engineer, what are you going to do with the data, right? You need to correlate that data to what's happening in production. It needs to inform your tests. And so do you need to improve your test suite? Do you need greater coverage, etc. So, in my opinion, for test engineers, quickly as things moving so fast, they need to understand data. They need some element, some level of data science experience or expertise as a tool now. Observability, user monitoring. That's all about what are you going to do with the data? What are you going to do? Right? So get the business value out of the data and correlate it to what's happening in your QA environments, dev environments, update your test strategy, your tests, etc. Right? So the skill right now, you need to know data. You need to know what to do with that data. That's my opinion. And what's happening in the industry, as I think, is validating my opinion.
And that makes a lot of sense, Donovan. Observability is definitely shifting the way QA professionals have been working or even thinking about testing,
Mm.
right? And it's very interesting and exciting to see how skills like data analysis, for instance, are just becoming so essential. So thanks for breaking that down. And just quickly on what you just mentioned, right? Do you also have any resources for QA professionals that how they can get started with those skills? Are there any recommendations for resources that you'd like to share with them?
So, as a start, understand what observability is, right? So getting into that. So you have something you have, let's call it alerting and monitoring. So that's a reactive. You're waiting for something to happen, and monitoring is going to wait for tell you something's happening, and it's going to alert, and then you're going to be alerted about that. Whereas observability is about observing your system in order to introduce changes to improve efficiency. So something that's slow, let's say a slow cart, might not, unless you've got a configured alert, might not generate an alert, right? Or the alert will be at when it's taking 5 seconds for someone to make payment, right? But leading up to 5 seconds, observability can tell you that, okay, 4 seconds is great, but we can get it down to 3. We're going to improve conversions by 15%, right? So it's under the sense of bringing observability. And that means your tester or your QA professional needs to understand business metrics as well, right? So there's observability, great, we can consume a lot of data, but we need to make sense of that data, right? So where to start? Um, go and research observability, real user monitoring, and it always comes back to mathematics and stats, especially if you're going to get into the data science components and understanding what to do with the data at a way more higher or way more level of sophistication. That, in my opinion, is important. Just going back to first principles, getting a solid understanding of math, and that's what you should get out of if you're doing a science-based or computer science degree. But that's not going to stop you from becoming great or really good at let's call it quality engineering. So yeah, that's where I will start. If you got no technical background, and even if you have technical background, um, I mentioned first principles earlier. I'm big on first principles. So chunking junk out. So if you're automating, rated automation, right? But the test design, the tests are not designed to expose certain classes of defects, right? So actually understanding how to design a manual test to expose different classes of defects, because that's the beginning, right? That's the basis, right? For us as quality engineers. Then automating that, and then putting observability on top of that, right? So then you get reliable data. So all the tech is amazing, but if the tests aren't efficiently designed or doesn't expose classes of defects or doesn't mitigate the risks of a regression pack, even if everything passes, should tell you, great, you can go live, right? Because it mitigates a certain type of risk, which you spoke about earlier, that if a user or your user community can't do what they normally do day to day, they become quite unforgiving, right? So back to basics. How does that test look like? Right? No technical knowledge. To me, the obvious thing: go and learn how to code in Python. Right? It's a super easy language to understand and to get quite far ahead if you compare to
Mhm.
Java, right? And there are Python wrappers around Selenium, around Playwright, etc. So then you can start doing that. And then moving on, learning behavior-driven testing, how to design your tests, your tests, really understanding that. So get to
Yep.
automate that. And we can go on and on and on. And from there, learning how to, Dockerize your test automation framework if you're going to build one. And then getting on to understanding TestOps. How can you farm off your test execution to using tools such as Lambda test, so you can do unattended test execution. Um, you know, so there's quite a bit. But if you're looking at the data side, I'd say go and do some basic data science courses.
Thank you so much, Donovan, for those insights and resources. I also wanted to just take a minute to, say that you run an amazing community in South Africa for testers. Kudos for building that. Just wanted to let our listeners know about, the community aspect of the work that you do too. So yeah, feel free to, once we publish the podcast, I hope that people can connect with you in case they have any more questions around it. So, moving on to the last question that we have for the day, what are your thoughts on future trends at the intersection of AI, observability, and software quality? And how might software quality evolve over the next 5 years as observability practices mature? And I'm sure it's a tough question to answer because the way software quality is evolving within like a fraction of seconds, or yeah, seconds even. It's a tough question to answer for sure.
Yeah, so if I'm hearing you right, how is AI going to
Yeah.
affect observability in the testing space? So the patterns, the user patterns that we were talking about, and all that data being collected and actually being able to make sense of that data. I'm pretty sure many organizations out there are already developing AI models or machine learning models to consume that data and start making those predictions. Yeah. This is why one of the reasons that I said that the future test engineer is also going to be a data scientist. That they're going to actually go into, in my opinion, building those models themselves. So from a job perspective, getting into data science, ML, and AI, and actually getting into building those models that can do that, consume that data and do the predictions from there. So from observability perspective, that model is going to consume the RAM data, so the real user data. It's going to it's going to be able to inform you. That's going to look at your test suite. It's going to inform you that there's a lack of test coverage over here, right? And then you can go to manual intervention and update that. But pretty soon it's going to be able to update the tests itself, right? That way, and be able to run those tests, right, to validate it, etc. So I think the future is exciting. It's also scary because as a test engineer, it means we really have to evolve our game and really step up more into the AI ML space, but with the domain knowledge of software quality, software testing, how to actually build those models using our domain knowledge, right? So, and as you know, AI means right now that domain knowledge is going to be supreme, right? So, yeah. So that's my opinion. How it's going to impact. It's going to be massive. But
Yeah.
as test engineers, as organizations that push out the professional services in the software quality space, the
Yeah.
organization itself also needs to evolve in that way.
Oh, wow. Future of software quality is definitely, dynamic. We are very sure about it. And I'm sure that
Mm.
everyone's excited to see how it all unfolds over the next couple of years. What also stands out is how the convergence of AI as well as observability seems like, it's going to redefine how teams ensure efficiency across the board. So
Mhm.
thank you so much, Donovan. It's been an incredibly insightful session. Really amazing insights that you've shared on how observability and RUM can, of course, transform software test modernization. Um, and to our listeners, thank you for tuning in. We hope today's session has provided you with practical takeaways to integrate RUM and also observability into your testing strategy. This is just one of the many thought-provoking conversations that we will be bringing to you through Lambda Test XP series. So stay tuned for more sessions. And Donovan, once again, just wanted to thank you for your time as well as for sharing all the insights. If there is anything that you'd like to share with our audience as we wrap, over to you.
Okay, closing comment. Um,
Yeah,
to your point about rapidly and how dynamic the industry we find ourselves in is, right?
yeah,
All of this, like I mentioned about 3 years ago, in conversation, was said that our future test analysts or test engineers have to become data scientists. So it is scary, I mentioned earlier, but I think as test engineers, quality assurance engineers, we just need to embrace it, take on the
yeah.
challenge, and really become, let's call it AI skilled test engineers.
Awesome. Thank you so much, Donovan, for those closing remarks. And everyone, stay tuned for more exciting sessions where we continue to explore the future of testing, automation, software quality with industry leaders. Until next time, stay curious, stay innovative, and stay testing. Happy testing. Thank you so much. Have a good day.